Hey SM2. This week we'll be covering 4.3, 4.4, and sorry, no 4.4, but 4.3, 4.5, and maybe 4.6. Um, but in any case, for 4.3, we're going to solve quadratic equations using square roots. And if you remember from 4.2, we solved quadratic equations by graphing. So here we graphed a function and looked for the x-intercepts, and that was solving quadratic functions using by graphing. Here we're just going to be solving a quadratic equation algebraically. So if you remember for algebra, the main thing about solving equations using algebra is that you have an equation. You have one side of the equation and another side of the equation. The goal here is to get one side of the equation to have just the variables. So in this case it might be x. So you want x to be on one side and the constants and everything else to be on the other. So we're trying to get x by itself. And in order to get x by itself, you have to perform inverse operations. So if you have 4x, well, this is the same thing as 4 times by x. So in order to get x by itself, you have to perform the inverse operation of multiplication, which would be division. So you'd have to divide, but whatever you do to one side of the equation, you have to do to the other side of the equation. So that's basically what we're going to be doing today. So here are some questions that we can answer as we go through. We'll come back to these questions, but basically, as we go throughout this lesson, try and think of these questions, or how you can answer these questions. How many solutions does, or I guess you could say can, a quadratic equation have, and how do you know this? And then how can you solve for the solutions? Remembering to think back on previous solutions that we've of previous things that we've done in the past. How do we find intercepts? How do we find zeros? Or how do we find the solutions? So we'll be answering that as we go throughout this lesson. So in this first example, so we want to solve the equation using square roots. So, like I've said before, there are operations. Okay, so for instance, you have addition. So if you have addition, well, the inverse of addition would be subtraction. You can also have multiplication, and the inverse of multiplication is division. Well, if we're going to be using square roots, we have to know what the inverse operation of square roots is. So we can have the square root of a. The inverse operation of the square root of a is exponents. So a squared. So exponents are the inverse operation of radicals. Exponents are the inverse operation of radicals. So this is exponents, and these are radicals, or square roots. Square root is a radical. So we have to make sure that we know these operations and their inverse if we're going to solve algebraically. So the goal for a is we want to get x all by itself. We want x to be all alone on one side of the equation. So you see how we have one side, the left side, and we have the right side. So what can we do to get x all by itself? So because we're subtracting this 27 on the left side, and I need to get this x all by itself, I'm going to add the 27 here, because whenever I add them, they will cancel out. But whatever I do to the left side of the equation, I have to do to the right side of the equation. So over here, the 27 will cancel, and then we'll be left with 3x squared equal to, and on the left side, we can add 0 and 27, so I get 3x squared is equal to 27. So now I need 3, or x by itself. This 3 is multiplying by this x squared. So I'm going to divide by 3, since that's the inverse operation of multiplication. But what I do to one side, I have to do to the other side. So when I divide by 3, those cancel. And then on the right side, I get 20. So here I'll have x squared equal to 27 divided by 3 is 9. So I have x squared equal to 9. And now again, so I have something that's being squared, the exponent. So in order to undo the exponent, I can perform a radical or a square root. So I can take the square root of both sides, because what I do to one side I have to do to the other. Whenever I do that, I get x because the radical and the exponent will cancel out. So that x is equal to the square root of 9, which we know to be 3. So x is equal to 3, except not quite. So again, when we take the square root of 9, we're looking for two numbers multiplied by itself. Two numbers multiplied by itself to get 9. So there's actually two numbers that could be plus or minus. So whenever you take the square root of a positive number, when you take the square root of a positive number, you get both the positive and the negative. So plus or minus 3 is the answer. Okay, so we got two solutions. So let's come back up here. So how many solutions does a quadratic equation have? How do you know this? Well, I know that it can have two. How do I know this? Well, if you think about it, when you graph a quadratic equation, it can cross at 2 times. So quadratic function a quadratic function can cross 2 times. Cross the x-axis. Okay, so how can I solve for solutions? Well, we know one, there's graphing. We learned about that one earlier. Algebraically, we know that one. Let's see if we can find more as we go throughout these lessons. Alright, so let's go to B. So solve x squared minus 10 equal to negative 10 using square roots. Okay, so just algebraically, let's see if we can solve this. So I need to get x by itself. So let's add 10 to get rid of the 10. But what I do to one side, I have to do to the other. So negative 10, positive 10, those cancel. Negative 10, positive 10, those cancel. So I get x squared is equal to 0. X is still not by itself, so in order to get rid of an exponent, I perform a radical. So I take the square root, but I have to take the square root of both sides. So when I do that, the radical and the exponent cancel, so I get x is equal to the square root of 0, and the square root of 0 is just 0. Okay, so here I just have this one answer, so x is equal to 0. Okay, so that's just one solution. 0 is just one solution. So I know you can have one solution, and we get one solution whenever our vertex touches the x-axis. So it doesn't cross, it just touches. So we can write that. So quadratic function touches x-axis. Alright, let's try C now. So let's subtract 11 from this side. What I do to one side, I have to do to the other. So then I get negative 5x squared is equal to 16 minus 11. I believe that should be That should be 5. Alright, now I'm going to divide by -5. So I get x squared is equal to -1. And I can take the square root of both sides. So the radical and the exponent cancel, so I get x is equal to plus or minus the square root of -1. Okay, so now I have to think of two numbers that multiply to be -1. So this is tricky because this is a negative number. So again, when you take the square root of something, you want to find two numbers that are similar that equal this number. So, but the only way to get a negative number through multiplication is by multiplying a positive and a negative number together. But if you multiply a positive negative, if that means a positive and negative number multiply by each other, this means that these are not the same number. Not the same number. Therefore, we cannot, there is no real solution to this, to the square root of a negative number. So, no real solution. Okay, what this means then is that we could have 0 solutions, real solutions. This means that the quadratic function doesn't cross or touch x-axis. So if we were to graph it, it would look something like this, or like this. Okay, so let's summarize this up in the summarize what we learned right here. So if you ever have x squared on one side, and we had this, so at this point right here we had x squared equal to -1. Over here we had x squared is equal to 0. In here we had x squared is equal to 9. So notice that whenever x squared was by itself, this was positive, this was negative, or this was 0, and this was negative. So if you ever have something like this, and the right side of the equation is positive, then you're going to have has two real solutions, and that's going to be plus or minus the square root of d. When d is equal to 0, this means you're going to have one solution, one real solution, and that is, I guess I should write x is equal to, and this is x is equal to 0. And if d is less than 0, or a negative number, this means you're going to have 0 real solutions. Alright. So solving a quadratic equation using square roots. Okay, so it's just the same process that we were doing before. It might be a little bit more complicated though, but not by much. So you see here that we have two sides of the equation, and remember that algebraically we have to get x all by itself. But notice here that we have x minus 1 squared equal to 25. We can't add this 1 because it's being squared right here. So we can't quite do that just now. What I can do is I can get rid of the exponent, of course, by taking the square root. So I can take the square root of both sides. So when I take the square root of the left side, I'm taking the square root of x minus 1 squared, which means I'm canceling the radical and the exponent. So all I have left over is x minus 1. And remember that this is equal to, now when we take the square root of a positive number, we get both the positive and the negative. So plus or minus the square root of 25. And we know that the square root of 25 is equal to 5. Alright, so now I have this negative 1 over here. I still need to get x by itself. So I'm going to add 1 over here and over here to get rid of that. So I have x is equal to 1 plus or minus 5. And this can be broken down into two different answers. So this could be broken down to x is equal to 1 plus 5 and x is equal to 1 minus 5. So here we have x is equal to 1 plus 5, which is equal to 6. And here it will be equal to 1 minus 5, which will be equal to negative 4. And these are the two answers. So x is equal to 6 and negative 4. Those are the two solutions. Okay. Now, so basically, just remember that you can take the square root of something that's x plus or minus a squared. I just want to warn you that sometimes you might have an equation that looks like this. So you can have x plus or minus a squared plus or minus k equal to the square root of, I guess we could say, b. In this case, what you want to do is get rid of this constant first by adding or subtracting it over there, and then once you do that you could take the square root. But just remember to obey the laws of algebra, that whenever you make sure that you're covering everything of like taking the inverse of both sides. Okay. Now let's go to example 3, and this will involve using a calculator. So approximate solutions of a quadratic equation. So approximate meaning that we're going to be rounding, and you're going to want a calculator for this. So it says solve for x squared minus 13 equal to 15 using square roots. So again, let's algebraically get x all by itself. So I'm going to add 13 here in order to get it out alone, but I also have to add 13 over here. Here they'll cancel, and then I'll have 4x squared on the left, and then over here I'll have 28. Okay, and then I can divide by 4, but then I also have to divide by 4 over here. The 4's will cancel here, so I'll be left with x squared equal to 28 divided by 4, which is 7. And then to get rid of this exponent, I can take the square root of both sides. So the radical and the exponent cancel. And then I have x is equal to plus or minus the square root of 7. So here I'll get x is equal to, I'll have two solutions. So let me go ahead and pull up my calculator. And you can use your scientific calculator that you have, or any calculator that you have. So I want to take the square root of 7. Enter. So my answer is 2.645. I want to round to the nearest hundredth. Okay, so this is, so we have the 10th place, 100th. Okay, so that's going to be 2.65. But then I also have the negative of it, which would be negative 2.65. And there you go, those are the two solutions right there. But that should be pretty much it. We'll probably do some extra practice problems in class, but just look at the homework and then refer back to this if you need any help. And make sure you just email me if there are any other or extra questions.